Chapter 3, Task 1, Linear Functions. Linear functions are ones that make a straight line. And they make a straight line when they're graphed. You can tell that a function is linear for 3 different reasons. First, it has an adding or subtracting pattern. Also, it has a slope or a constant rate of change. And lastly, when you're looking at the equation, if it has no exponents, then we know it's linear. Usually when we're talking about linear functions, you're looking at equations that will look like this, where y is all by itself, the slope is in front of the x, and the y-intercept is at the end. This m stands for slope, and this b stands for the y-intercept. If it doesn't look like that, then we need to solve for y and help it to look like that. And we'll do some examples in a minute. So in our first example, we're going to sketch the graph of this equation. We can tell that it's linear because it has no exponents. It's in this form. And what's the other reason? It has a slope. See how I checked my notes? So before we graph, it's always a good idea to identify the slope or the m. In this case, I'm going to write the word slope and the y-intercept. The slope is the number before the x. So this here, whatever is in front of the x, I'm going to identify as the slope. We like fractions, especially because we know that slope is rise over run. And then the y-intercept is whatever's being added or subtracted. In this case, we're subtracting 4. So we're going to take the negative with it and call that -4. Our next step is to graph using this y-intercept. The y-intercept always, always, always goes on this axis right here. I'm just highlighting it so that you know it goes right here on this axis. So if I am going to graph -4, I'm going to start at the origin as always. And I'm going to count down 4. 1, 2, 3, 4. I'm going to put a big fat dot for my y-intercept. And then from this dot, I'm going to look at my slope. Rise is on the top, which is a 2, and run is on the bottom, which is a 3. So from this dot, I'm going to rise 2, 1, 2. I'm not going to put my dot. Instead, I'm just going to rest my pencil there, and I'm going to count the run, which is +3. So I go right 3. 1, 2, 3. I want to do it at least a couple more times to make a good plotted line. So again, from here, I count up 2, 1, 2, and then over 3 before I plot my dot. 1, 2, 3. I'll do it one more time. Up 2, over 3. Then I always like to have some sort of dot on this side so that I have a straight line. So I'm going to do the opposite. Instead of going up, I'm going to go down and left. So 1, 2, 1, 2, 3. And that looks pretty good. So then I'm going to make the straightest line possible without a ruler and put arrows on the end. This next example is not in slope-intercept form, so we're going to have to do some work. The whole goal here is to get y all by itself. When I take a look at it, 2x is being added to 5y. So there are going to be 2 steps to get y all by itself. First, I want to subtract the 2x from both sides. This guy cancels. I'm left with 20 minus 2x, and I'm just going to rewrite it so you can see it. 5y equals 20 minus 2x. I can't plug in my calculator 20 minus 2x. They are not alike, so I'm just going to put them side by side. The next step is to get rid of this 5. If I read this out loud, this would say 5 times y. I always do the opposite or the inverse operation of, in this case, it would be multiply. The opposite of multiply is divide, cancels. What I do to one side, I have to do to everything on the other side. So I'm going to rewrite y equals. It's probably best to put this guy up front because we want our slope in the front area here. So I'm just going to rewrite negative 2 over 5x. We do not want to plug that in our calculator because you'll get a sloppy decimal. And in slope, when we're graphing, we like for our slope to be in fraction form. And then this guy, I'm going to put at the end, it says 20 divided by 5, which is a positive 4. Now I can go ahead and identify my slope. Another way to write the word slope is m, and y-intercept. The slope is the number before the x. So in this case, I have a negative 2/5. Make sure you take the negative with it. And the y-intercept is whatever's being added or subtracted at the end. Since it's plus 4, that means I have a positive 4. I'm going to go ahead back over to my y-intercept, and I'm going to start with a big fat dot on positive 4. That means we go up 4. 1, 2, 3, 4. Big, nice dot. The slope in this case is a negative, so I know my line is going to be going down. So the rise would be down 2 and right 5. I'm going to run out of graph possibly. Let's see if we can squeeze one more in. From this dot down to 1, 2, over 5, 1, 2, 3, 4, 5. We made it. And like I said on this example before, we're going to go the opposite direction so that I can have a nice straight line that crosses the y-axis. So I'm going to go up and over, 1, 2, 3, 4, 5. Up and 1, 2, 3, 4, 5. All right, and that looks pretty good. I'll make the straightest line I can without a ruler. Put arrows on the end indicating that that line goes on and on forever. So as you learned in our other chapters, hopefully, we're going to definitely use Desmos for this. Points are solutions to an equation if they are on the line. Again, this is a great task for Desmos. So in just a second, I'm going to show you an example for the following. So for this next section, we're going to choose all the points that are solutions to the equation. And I had to take a second to write that down because it wasn't on my paper. But to do this, I'm going to ask you to open up Desmos. Definitely. So go ahead and do that right now. And your screen should look like mine. And you're actually going to type in that equation. Make sure when you do the fraction here, you put in 4/5 and it will create a fraction bar. What I found is important is that you hit the arrow key over to get out from under that fraction so that we can put our x. And it looks like it's +6. And as you see, it'll make a straight line. So that's the first step. The second step is to take the first coordinate point, and you see how I did that. I went up, I pushed the plus button and fx expression here, just the first one, you choose it. And we're going to go ahead and put that in using that parenthesis. And the first one is 0, 6. So I'm going to do 0, 6, and it closes it for you. So we're going to look over here, and as you can see, and you can also make this smaller or bigger, as you can see, that dot falls straight on the line. And if you're unsure, you can click that dot and it says 0, 6. So it shows exactly it's falling at 0, 6. Yes, it's on the red line. So yes, that is a solution to this equation. So let's go ahead and type in the next one.